we will start our session. So, for those of you who are considering joining the program, I will be the faculty of the program. So, you will probably learn from the person who is going to interact with you, and what you will learn, and how this course is very different from any such course available on the web, and how we strongly believe that this course can revolutionize, give a jump start, and do the transformation of your career. Right. So that is the introduction. So I would like to, in the next 40 minutes or so, answer 5 important questions. The first question is, hey, what is deep learning? Some of you may already know the answer, but I want to still address that in a very, very 5,000 feet kind of manner. A very important question actually starts from there. Why is it relevant today? Why should you learn deep learning? And then, through this course, what job are you preparing for? What does this course get you to take up? And a natural consequence of that is, how is this course very different in preparing you for that extremely critical and a large number of jobs that are opening up in the industry. And then I will actually get into some detail of what we teach in the program, and answer what software background would you require to do this program. So those are the questions that I'll answer. And now what I request is, towards the end, we will have a question answer session, which will open up, at which point, whatever questions you have, you can ask. And during the session, if you have a question, just type in the chat window. But please note that I'm not going to look at the chat when I'm talking. So you type in, and towards the end, I will answer any questions that are in the chat window one by one. Thank you. So, deep learning was inspired at some level by human brain. Human brain had these millions and millions of connections that somehow seem to be making us intelligent and smart the way that we are. In fact, any living being, of course, any advanced living being, has in its brain these networks. So for a long time, people were thinking probably these networks, if they are constructed well, are one very powerful way for humans to create brain-like systems, intelligent systems. So the press started in actually 1880 was when the first system was built. The system that you are seeing here was called logistic regression in the early 1900s, and by 1949 a slight variant of that was called, the name was called perceptron. So this is the first of the models that people built. And interestingly, even today, more than 90% of the industry analytics professionals rely on this technology. And that is where really one needs to understand whether we have a chance to progress things forward. So, perceptron or logistic regression is a very simple representation of human brain. Obviously, one who sees the previous slide and this slide knows that this slide is very limited. What you can accomplish with this is very limited. In the course, you will learn why it is limited, but intuitively, there are billion nodes there, and there are 4 nodes here, so that makes it extremely simple. Now, by 1985, people progressed a bit more and developed what are known as multi-layered perceptrons or artificial neural networks. If you see from perceptron to neural network, the growth is one extra layer in between. Essentially, by 2010, people really understood how to add 1 or 2 layers in between. But so actually a whole bunch of problems that were not solvable until then became solvable with the advent of our insertion of just this one layer. And then in 2010, the true revolution started. And what we are now looking at are systems that have dozens, if not hundreds, of these hidden layers. A typical system has 8 to 10 layers. The deepest net that people have built so far has around 153 layers. But we now have a system that is extremely deep, that is very intricately and complicatedly connected, and that seems to be solving some really interesting problems. So the evolution of neural net can be seen as a construction or an architecture that is inspired by the brain and evolved over 60 years from a simple zero-layer input-output to a many hidden layered system, right? Now this is what you will be learning in this course. You know, how to go from that no layer to many layers. And why should you learn it? The simple answer here is, as of today, if you are looking at solving any problem with images, to the best of my knowledge, there's no other technique that is anywhere nearby, not even a competition. These neural network techniques are by far orders of magnitude more impressive and accurate and efficient than any other known technique to mankind. Text, many applications, translation, classification, language translation, English to Spanish. A recent release by Google actually was better than a human translator. Classification, sentiment analysis, clustering, grouping of news articles into Google News or anything like that. Chatbots, question answers. Again, no other known technique is anywhere near. So, images and text, deep learning by far is the de facto standard today. People don't, the first thing they try is some kind of deep learning. However, my personal interest has not been either images or text. I'm much more interested in regular structured data and solving problems that are important for business. So, can we tell whether this customer is likely to buy or not? Can we forecast the demand of a product in the next quarter? Can we decide whether the transaction is fraud or not? Can we build a recommendation system in my e-commerce site that recommends the right product to the right person? Can we build a customer segmentation application? Now, these are the problems that businesses are working on are really interested in solving. And all the problems that I have encountered in my consulting in the past dozen years or so, I have put together in this chart as individual boxes. And except the 2 red boxes that are shown here, deep learning, in my experience, had beaten the benchmark in everything else. So, I was talking to a very senior person in fractal analytics a few days back, and he put it rightly. He said, deep learning is today's regression. People believe this is one technique. If you want to learn just one technique and still solve most of the problems that data scientists solve, this is the technique that you should learn. So, at least at this point, there is no other method that is developed by human beings that comes anywhere close to this technique in many varieties of applications in structured text, image, IoT kind of data, any kind of. So that is the reason to learn deep learning at this point. Now, what job will this course prepare you for? See, deep learning can be learned at 3 different levels based on, I have conducted several training programs at various levels in an organization. The 2 levels that we will not be interested in this course are represented in light gray here. One is for CXOs. the CXO just needs to understand, hey, what can deep learning do to my organization? What kind of infrastructure should I need to provide? And most importantly, what kind of business model should I pursue? Should I outsource it? Should I build an in-house team? If I have to build an in-house team, what competency should I have? This is the level of understanding that a CXO needs to have if they want to implement deep learning in their organization. Now, engineers on the other hand need a lot more work. They need to figure out how to code various libraries that are available, and they need to also know other machine learning models, statistics, big data, and experiments that help them jump from one to the other so that the best possible model is built for the given system. What I am interested in is, in this course, the architects. The job of this architect is to transform the CXO streams. The CXO has decided to implement deep learning in his or her organization, and there are quite a few CXOs like that in the country now. What they don't have is mid-level techno-manager architects who can transform the CXO dream into reality. Actually, engineers is not as big a problem. The bigger problem is these architects, finding the right architects. And what is the job of this architect? Number one, you, at the end of this course, if you want to be an architect, should be able to identify for your organization what disruptive products, services, and processes you can develop using deep learning. You need to be able to spot what is important. And once you spot them, you need to be able to work with the business to understand their needs and translate it for the technical team. And trust me, in many of my consulting engagements, the biggest problem is to extract from the business what they need. And over past 10 years or so, we have developed frameworks and tools that enable us to do that process very efficiently, and that is what we believe every architect should have in their team. And then what do I mean by leading a team actively? There are many decisions that deep learning architects must take that allow them to lead the engineering team actively. It could be a different thinking about the data. It could be a different thinking about how do they measure and validate the model. It could be a different thinking about what experiments they should do to improve the accuracy or performance of the model. It is not building or coding the deep learning that is really the difficult part. In fact, if anything, that's getting easier and easier with the kind of libraries that are available. However, what is really important is for the architect to be able to lead this technical team actively. And then once you build a system, the architect has to also understand how to productionize the system, which means it should be robust, manageable, give the performance that is desired. Democratize. It should be used by every potential applicant that is interested in using it, and of course train them to do that. So this course is aimed at giving this entire training. So the idea here is not giving a technical course, and let me be honest with you, I personally have seen some phenomenally good courses by Stanford, Coursera, on the web for the technology. They are fantastic. Of course we teach technology, but what we teach is how do you implement this technology in business. That is most important. So, and we have not honestly found a single course anywhere on the web that covers this. And the reason for that is, I believe this is not as it is not a programming course, we need to take business case studies. We need to do case analysis like in a B-School. The program that we have designed for this course requires 4 architectures, 11 case studies, and several deep learning frameworks that we implement to build products and services for our clients. So please note, This is not another course in deep learning. It's not a technical course. And it is a course built exclusively for the senior professional. Of course, you will become very comfortable leading a tech team, but that is not the sole and whole aim of this course. What we really want you to be able to do is to go to the CXO, either in your organization or in the new organization, and tell, hey, you know what? I will make your organization deep learning ready. I will hire a few deep learning engineers. I will work with your business, put together the right products and services, take up the challenge of building the right products and services for your business. And how do we accomplish that? What do we teach to prepare you for that? It's 6 days of that learning. It is a very rigorous course. You have to work pretty hard, and this is how we structured it. Day 1 is about deep thinking. So the entire day, we actually work on giving you this and helping you practice this new framework of deep thinking. And trust me, it's very different. It's extremely different, even for a machine learning practitioner. Actually, more so for a machine learning practitioner, this requires unlearning. Many things that you do in machine learning actually are wrong practices in deep learning. So you will learn why it is a different way of thinking about problem solving, why it is a different way of thinking about data, different way of thinking about models that you have built, and different way of thinking about validating models, different way of productionizing models. You will learn the frameworks that help you deep think. And we will take several use cases, several problems, exercises, interactions to get you into the track of deep. Day 2 and 3 where you will learn building linear, non-linear, and deeply non-linear models. We will show you how to do all this and in a very simple, non-mathematical, and interestingly non-programming kind of a way. I'll talk about programming in the next session. But we have worked, personally I have spent months and months figuring out how to simplify this mathematical concepts in a way that business really understands, gets what is important. And by the way, we are not shirking away from challenges. By the end of that program, you will be able to understand when to use which of these linear, non-linear, and deeply non-linear model, and you will have worked on several applications where you will have broken benchmarks, the state-of-the-art results. You will have seen a recommendation engine that is better than products that are commercially available, fraud detection, forecasting, and a lot more. So by the end of day 3, you will be ready to architect any problem on structured data. If the data is from a database, you will be ready to handle it by the end of day 3. And you will then get 4 days break. It's not exactly a break. That is when you will do your mini project, where we will provide you a code. You don't have to code it. We will provide you the code, and you learn the experiments. You apply the experiments that you learned on day 2 and day 3 to improve the accuracies. So typically as an architect, you won't be starting with the rough, bare code. Your engineer will have developed some code. So the focus here is looking at that code and figuring out, hey, you know what could be done right? And you will experiment all that. And then you will also apply it on some data, and we will provide you some data where it is applied. You will look at the errors, analyze it, and then suggest what experiments you should do, and do those experiments and improve the performance. So the mini project is not about a coding exercise. It is about an engineer has built a code, and as an architect, you have to actively guide that engineer to make that code. And that is what you practice in that mini project. And that takes you to the next 3 days. Day 4 and 5 is all about images and text. In images, you will learn a new architecture called convolution neural nets. And one of the applications you will see, and you will see state-of-the-art applications. One application that you will see is face recognition. Another application you will see is mood detection. So, given a photo, can we detect whether the person is happy or sad or depressed? Just to give you an idea, recently an insurance company has used mood detection, something like that you are building, to decide how much of insurance premium they have to charge from that customer. If that customer is very depressed, the premium will be higher. If the customer is not depressed, the premium will be lower. So the applications that you are looking at are, every one of them has a real world elements. We will not do differentiating between cats and dogs. I'm not denying the fascination involved in that project, but the idea here is in those 6 days we want to get you as close to industry problems, most of the industrial problems as possible. And then in text, you will actually look at how to build a chartbot. And the reason why we combine text and time series is that for both of them, context is important. In a time series, how much money my company is going to make in the next quarter? What will be the demand of this product in the next quarter? To determine that, we need to know what are the past demands, past revenues of the company. Similarly, to do any text problem, we need to know a lot of the past text that is available. So text and time series are sequential data, and you will learn a lot of applications, and you will see state-of-the-art time series analysis built with simple architectures that you have learned until that point. Basics, of course, you now know how to build a structured data application, the image application, and a text application. In structured data, you know time series. Now we will learn how to visualize whatever results that you obtain, how to productionize, what mistakes people do when they are productionizing, and what practices one should ensure to certainly ensure that the product built is used by the teams the way it should be used. And very interestingly, we will also spend time on what are the limitations of deep learning. Why, as a human architect, you still have a very active role to play is something that you will learn. What deep learning cannot do is a very important thing for an architect to know, and you will learn that. And of course, we will also, this is a field that is growing so fast, we will point you to some of the exciting developments that are happening that you should be aware of as an architect, for in your future. That takes you to the second project, where we will give you a complete case. We will give you a business scenario. You have to identify what deep learning process, product, or service you need to build, what kind of data you need to build, and we will then give you access to some data also and some code. Now you apply that code on the data. You define what other metrics you should really care for that particular business case. Look at those error metrics, define, analyze how the model is working on the data based on this model, and write a experimentation scheme and implement those tests and experiments, improve the accuracy, and also draft a complete plan of productization. So this, we expect you to spend approximately a month, 40 to 50 hours doing this, and we will support you periodically while doing it. But if you work on this problem, this could be the single most important thing that you can convince your any organization that you are the right leader that can handle any deep learning challenge in your organization. So the entire 6 days are spent, if you look at it, on technology and the business implementation of the technology. Most importantly, the business implementation of the technology. And we recognize that business implementation involves two aspects. One, interfacing with the business folks who do not understand your technology. They hate math. They hate equations. You should not do anything other than visualizations for them. Nice, simple graphs is all they care for. And then it also involves leading a team of engineers who love nothing but math and equations and code. So this is a very, very interesting role and very little available. It is easy nowadays to find good engineers actually. Any engineer with any discipline trained for 6 months can code a reasonably powerful deep learning software easily. Similarly, business guys believe deep learning is a myth and anything can be done. So the organizations and CXOs are looking at those who actually understand, who can understand their business well and interface with these two and design not just a technology code, but a product or a service that they can implement that delivers value, right? That is what this course teaches you through extensive amount of case studies, interaction, and of course technologies and code. Right. The last question that I would like to address is, what software do you need to know? It's interesting. Actually, I developed the entire course in Excel. See, it's an architect's job, right? So I said if an architect has to do it, the entire course has to be just restricted to spreadsheet. So I actually built a convolution neural net in Excel. But then gradient descent, paragraph. Yeah, right, it can be done. But obviously, none of your engineering teams are going to use Excel in a production environment. That is true. It is very, very useful for us to understand the underlying mechanisms, but it is also essential that you understand how the real production code looks like. You get exposed to that. That's why the de facto standard in deep learning today is Python. Google uses Python, Facebook uses Python for its deep learning. So the TensorFlow, Keras, all those are the state of the art in that. So what we have done is we created code that your engineers would have developed in Python with enough comments, tags. What you will learn, you will get all your intuitive understanding through just spreadsheets, mostly. I will show you some code, but your experimentation is not, the emphasis is not on the coding. The emphasis is you have this code that is written by the engineers. How do you analyze? How do you experiment with this code? How do you design the right process? So that is what you will need to learn. So what software do you need to know? Well, any software language, if at any point in your life you coded, if you can understand the simple structure like, hey, how do I execute a for loop or a if conditional? What happens? How do the computer programming work? And we will also talk about some simple classes that we define. But again, you will not be coding this. You will be given the code because we believe as an architect, very, very rarely, if at all, you will be coding. You will be working with engineers who will have built the code. And the code that you get in this course probably will be a good enough starting point. Even if you want to build a simple application of your own, it is going to be an issue of getting the right data, changing the directory structures, etc. in the course. You will receive probably a state of the code for top 5 to 10 most important applications, figuring out someone will buy a product or not, figuring out whether a customer will churn or not, a recommendation system, a forecasting system, detecting the image, yes or no, text classification, text forecasting. You will have code for all this, and we'll sit next to you and walk you through this code step by step, so you know exactly how to write it. So at the end of the course, while you may not, you will be easily able to plug in any data set and solve many of the simpler problems. But most importantly, any complicated experiment that your engineers have coded, you will be able to understand, pinpoint exactly what are the new things that they need to do to improve the performance. And how do you visualize the results of those complex models? Those are the things that we will learn. And for that, we we have figured out a very nice and smooth way in which architects can become masters of it. Right? So that's basically what I wanted to cover in this small information session. I hope I answered your questions, some of the questions that Som shared with me that you have in doing this course, like what kind of job you are preparing for, what kind of software background you need to have, what actually will you learn in this course, and why is this course different from the free courses available on the net. And again, I would like to state that very clearly. There are fantastic deep learning technology courses available online. The goal is to learn. Of course, the classroom program has this advantage that 6 days you're coming, sitting there. So in 6 days, you will become really, really good with this. That is one advantage that any classroom program obviously has, because most of the online programs, we stop and we drop. We start and we drop, and we again come back. So it will take much longer and much more time consuming. But the bigger difference is not just that imposed discipline. The bigger difference is actually making deep learning a business reality. And every aspect of deep learning technology implementation will be covered in this course, and not just the technology of it. Thank you very much. Now I will wait for your questions. If you have any, can you please type your questions on the in the chat room? I will be answering. We'll sit here and we'll observe and we'll answer as many questions as you have. Yuvendra, if possible, you can unmute also. If someone just says, I have a question, you can unmute them, or they can talk into the system if their audio is good. Nagendran and two others are typing, so okay, I will wait for them to type also. That's fine.
Yeah, I just posted if I am audible. So my question was regarding unstructured data, because if you see, one is of course structured data. There are plenty of BI tools already available, but yes, I do understand for the objective of this one is completely different. But unstructured data forms a big part, right? So
right. Sure.
We cover that?
Probably you joined a bit late, Nagendra.
Yes, yes.
As I mentioned.
I had trouble in joining, so I joined late.
So here, if you see, day 4 and 5 is completely dedicated to images, text, CNNs, recurrent neural net, LSTMs, the latest that's happening in images and text. I also talked about the applications, face recognition, mood detection, chatbots. These are the applications that we'll cover. And deep learning is actually very, very attractive in unstructured data, so we cover. And of course, the day 2 and 3, on the other hand, are exclusively dedicated to structured.
Okay. So basically, that means that even data from sensors and all that, which is used for predictive analytics, forecasting and all that, that is also covered.
Exactly. Right? Yes.
Okay.
Yes, very much. And we actually take one of the use cases that we cover is on sensor data, how we actually built a system that computed the exercise that is done by the people who are playing Kinect games and designed a alternative biomechanics treatment for these guys. So sensors is covered, and the text, image, and of course structured data.
Okay. Yeah. Thank you.
Yeah. Welcome. Just for Nagendran's interest, So I understand you joined a bit late. So the recording of this will be available the first half an hour. You can please contact So to get that. Right. Babu, that's a good question. Not for this course, no. In fact, this course prepares you from the ground up, assuming that you don't have any idea. In fact, I don't even assume a machine learning background. Zero background. You could have been an engineer with 10 years of experience. You are working on databases, writing SQL queries, let's say, or doing e-commerce applications. We have built a course for that. So for this course, it is not a prerequisite that you take any other course. On the other hand, Andrew is a very good professor, so learning is always a good thing. So if you want to take additional courses, of course, he's a great teacher, right? So it is not a prerequisite at all. In fact, I spent weeks and weeks building the course such that it doesn't expect anything other than business knowledge and some basic coding knowledge and familiarity with Excel. So those are the three things that I take as required inputs. Any other questions? Welcome.
Hi, Nagendran here again. I just typed in the query. Apart from the 6 days of classroom, hello.
Yeah, I'm listening.
Yeah. Oh, sorry. Apart from 6 days of classroom training, is there any online this thing or a video or something courses which we have to do before the 6 days or after 6 days?
No. So as I said, before the 6 days, there is none. There is one session that we do to help you install all the software that is, on which we show the code, etc. So that's just a 1 hour session. Post the course, we actually give you a project, and that project involves you. Because Nagendran, as you joined a bit late, let me talk about again the emphasis of the course. During the program, you will be given a lot of code that is most likely generated by the engineer. So this is a course that is preparing you as a technology leader. So we assume a scenario where you have a few engineers that develop code for you. And we'll take up a variety of problems where the engineer developed code is what we give you. And what we teach in that course is how to analyze that code, what is right, what is wrong, and how do you actually make it better is what we teach you during that program. Now, there are two interventions here. After the first 3 days, you do a mini project where we will give you a code and you will have learned a lot of experiments beforehand in the first 3 days. You will run all those tweaks, what if I add one more layer? What if I change this to that? You systematically, it's not a random way of doing. You will learn a very systematic way of building it. We will give you a business problem, we'll give you some data, we'll give you a code that engineers developed on that, and you will systematically improve the performance of that. So that session helps you lead a technology team actively. Post the 6 days, you will have one more project. This time, you will actually we'll give you a business scenario. You need to now design a product and look at the code developed for that product. And when I say design a product, you need to understand what kind of data you will use, what kind of error performance metrics you will use, and what kind of analysis you will use. And then take the code, run it on the data, analyze, come up with the results, and visualize, productionize. So you will go through the end-to-end process in the schema. And for both of them, both of them are not done during these 6 days. These are done and we will provide you guidance online. So there's no recorded version of courses that we ask you to take. We'll cover everything in the classroom, but we believe after working with several participants in several scenarios, having the participants work on projects is a very good way to give them the confidence to face any challenge coming up. So we will have you work on projects.
Okay. Yeah. Thanks for that. So one more thing, you emphasized upon having not to develop the code ourselves, but just to clear my doubt, see, I come from a completely BI background, and my comfort has been on SQL, and for quite some time, at least I moved on from a hands-on role to more of a managing technology teams. So do you think that would suffice, or any programming?
As I said in the last slide, actually, I initially designed the entire course in Excel.
Okay.
So I believe people to understand deep learning, you have to code, but it doesn't matter if it's Excel. It is just that Excel cannot deal with the data that you have, and
it cannot be used for production.
Python, right? But so the emphasis again is not on coding at all. I mean, we give you 10 to 12 real world code. So the focus, what we teach you is, your engineer has given you this code. How do you improve it? So you will need to read the code, read for the problems that are there, and guide them in the right direction. So if you are comfortable with SQL, if you are comfortable with the logic of that, you should be good to go. It is just that on day one, you will spend some time reading a Python code that is given to you. But, that's a very smooth learning curve. Probably it will take. And I just offered this course in Columbus 1 month back. And the topper in that batch was a BI analyst with 15 years of experience. And last 12, 13 years, he did nothing but SQL. So definitely that is more than adequate for this group.
Okay. Thank you.
Okay. If there is no other question, as I said, the recording of this presentation will be available. So in case you want more about it. So thank you very much. We will turn off the